Welcome back. We'll now do the inverse transform example 3. This is page 29 of the chapter 4a slides. Right. Again, we are given XA, and this is a second order. So what we do is that we are still going to use MATLAB to perform the partial fraction expansion. But again, you're asked to do it by hand. Now, observe, this is 5, so I'm going to put 5 here. 5 is with respect to power 0. There's no power 1 of s, so this is 0, and the power 2 of s is 2. What about a? It's easy. The first power of 2 is 1, power of 1 is 3, and 2. And then all we need to do is RPK of this. So this is RPK for residual BA. What's our answer? Well, this is our answer. R is minus 13.7. P is minus 2 minus 1. K is 2. So what do we do? Well, the form is R1 divided by S minus P1 plus R2 S minus P2 plus K. So let's substitute the value. R1 is minus 13 over S minus minus 2 plus R2 is 7 S minus minus 1 plus 2. So the answer is minus 13 S plus 2. 7 over S plus 1, and we have 2 here. By the lookup table, it's easy. Minus 13 E minus 2t plus 7 E minus 1t. We have a ut here because we are doing unilateral transform, and that 2, if you look at the lookup table carefully, the Laplace transform of the delta function is 1. Since this is 2, it is 2 times the delta function. So this is the time domain signal for this XS. Now we'll do the second one. Again, we set B is equals to, the exponents are 2, 7, and 4. 2, 7, 4. The coefficients of the S's are 2, 7, and 4. A is, now we have S plus 1 and S plus 2 square. So you can try and open it up by yourself, and it'll be a bit difficult. So we're going to be a little bit lazy, and we're going to say it to be the convolution of 1, 1 multiplied by, or let me be very clear, it's the convolution of 1, 1 with the convolution of 1, 2, 1, 2. Now, if this confuses you, what we are trying to do is we are using the convolution operation to perform the multiplication in the time domain, or sorry, in this expansion. Okay, now let's proceed. I'm going to use MATLAB to show you what I'm doing. Let's try convolution of 1. Right, I type out the expression, this convolution here, and the answer is 1584. Now let's see what this 1584 means. 1. So let's write the coefficients. 1584. So this is plus 4 is 8s plus 5s squared plus s cubed. So 1584 are the variables associated with the s. 1 is for s cubed, 5 is for s squared, 8 is for s, and 4 is for s to the power of 0. Now, you can learn how to use convolution to perform multiplication in this expression over here. Right, so if I might be wondering what is this 1, 1? Well, let me draw it in green. This 1 and 1 here is 1s plus 1. So this is the two coefficients here, 1 and 1. What about 1 and 2? So this is 1s and 2. So this is 1 and 2. Why am I convolving against himself? It's because I'm actually trying to do s plus 2, s plus 2. So multiplication here becomes convolution there. Okay, so we have b's and a's now, and of course he called it the numerator, which is 274 here, the denominator, which is 1584, and then we do RPK again. So this is R1, this is R2, and this is R3. So we have three of them. Now this is interesting. P1 and P2 have the same value. So this is called something called repeated roots. And for repeated roots, we have to deal with it slightly differently. And this is P3. And K is nothing. So typically, you have written it as R1 over S minus P1 plus R2 over S minus P2. Now, because P1 and P2 are repeated, you have to do something different. You have to use S plus 2 squared. Okay, so this is the difference because this is a repeated root. So because P2 is equals to P1, so we have to deal with it this way. Again, look at partial fraction expansion examples and tutorials, and look under repeated root, you'll see this condition. And the last one, of course, is plus R3 S minus P3. So let's check. R1 is 3. S minus 2 becomes S plus 2. So the first expression is correct. R2 is 2. S minus 2 is S plus 2. But here is the square because of the repeated root. The last one is minus 1. S minus 1 is S plus 1. So there we have it. Okay. All right. Now, once we have this in this form, over here, then again, simply we perform lookup table. This is trivial. This is 3 over S plus 2. This guy is 2 over S plus 2 squared. This guy is minus 1 over S plus 1. The whole thing is multiplied by UT. All right.